All right, so we're going to find the x and y intercepts of a function. So if you think about, let me draw an x and y axis over here. So if you think about the x-axis, the y-axis, if I want to find the y-intercept, of course, it's just where a point crosses the y-axis. I should say where a graph crosses the y-axis. And the x-intercept is simply where a graph crosses the x-axis. The zeros of a function, they're what we can plug in to make the function equal to 0. And that turns out to actually be the same thing as the x-intercept. So if you find an x-intercept is also a 0 of the function. Now, if I'm trying to find a y-intercept, if I'm on the y-axis, no matter where I go, look at all those points as I go up and down the y-axis, what we know is that the x coordinate has to equal 0. So to find a y-intercept, we actually did this with linear equations, but we plug 0 in for x, because if I'm on the y-axis, x has to equal 0. If I'm trying to find the x-intercept, if I'm on the x-axis, in that case, y has to equal 0. So to find the x-intercept, we plug 0 in for y. And then again, the x-intercepts are also zeros. Sometimes I may ask, find the x-intercepts of a function. Sometimes you might be asked to find the zeros of a function. You're finding the same thing. You're trying to find out where the graph crosses the x-axis. Let's go ahead and do this. So this one, the graph's already given to us. So if I ask you to find the x-intercepts, see it crosses at, that's -4, 0. And when you write an intercept, it should be written as a point. So the first x-intercept's at -4, 0. The other one is at -2, 0. Okay, y-intercept. Well, that's where it crosses the y-axis. So that's right up here. And that is at, let's see, 1, 2, 3, 4, 5, 6, at 8. So 0, 8. Now, a lot of times what happens is you won't be given the graph. So if you're not given the graph, so let's do this algebraically rather than just using the graph. Let's actually start with the y-intercept. To find the y-intercept, we just said you plug 0 in for x. So if I plug 0 in for x, I get 0 squared plus 6 times 0 plus 8. Well, that's 0, so it goes away. Plus 0 goes plus 8. It just comes out to be 8, right? So you can find that y-intercept if you are given the graph. You can use the graph. No, on your assignment, you're not going to be given the graph, so we're going to do it algebraically. So we're going to do it the way we did over there. Plug 0 in for x and see what happens. Finding the x-intercept can be a little more complicated. So we said to find the x-intercept, you plug 0 in for y. So I'm going to plug 0 in for y. Okay, then I want to solve for x. Well, that's a quadratic equation. So we've solved these. It's been a little bit, but we've solved these before. So if we want to solve, one of those two. I think this one factors, but the quadratic formula is fine. It works great. So if we try factoring, do my two sets of parentheses, x and x. What are the factors of 8? Add up to be 6, so it's plus 2 and plus 4. Cut each of those equal to 0. X equals -2. X plus 4 equals 0. Okay, so those are, right here, my two x-intercepts, which we already found because we have the graph. But if we don't have the graph, that's how we're going to do it. We're going to do it algebraically like that. So a lot of times when you find the x-intercepts, it does require solving a quadratic equation, which is a little more difficult. It takes a little more time consuming. Finding a y-intercept is usually easier because all we do is plug 0 in for x and work it out. So let's do one now where we're not given the graph first. So it says find the vertex, y-intercept, and zeros of the function. So a couple things. For now, we're going to skip over. Actually, no, let's do we can do the vertex. But we're going to save that for just a second. But we want to find the y-intercept. Hey, the zeros, just remember those are the same as the x-intercepts. Right? You could be asked either way. Okay, so let's start. I'd always start with the y-intercept. That's the easiest one. Okay, so to find the y-intercept, we just plug 0 in for x. So I get 0 squared plus 2 times 0 minus 3. So the y-intercept, that comes out just to be -3. So I plug 0 for x. and got negative 3 for y. Okay, let's do the x-intercepts. Okay, for that one, we plug 0 in for y. Okay, I'm going to try solving by factoring, but factors are negative 3 to add up to be 2. I think it's positive 3 and negative 1, right? You times those and get negative 3. They add up to be 2. Set them both equal to 0. X plus 3 equals 0. X minus 1 equals 0. So I get what? Negative 3. So negative 3 is 1. Negative 3, 0. And the other one, if I add the 1 over, be positive 1. So those are my x-intercepts. Let's put all that information on the graph and see if we can figure out where the vertex is. So we go to 0, negative 3. That's my y-intercept. Negative, let's see here, negative 3, 0. And 1, 1, 0. Okay. So to find the vertex, you can do one of two things. We can use our formula that we've already learned, that negative b over 2a. And that works great. But if we already have the x-intercepts, one trick we can do is, if you look at the axis symmetry, if I go halfway between my x-intercepts, right there, that has to be where my axis of symmetry is. So my vertex has to be somewhere on that axis of symmetry. And so that's at when x is negative 1. So I know my vertex is when x is negative 1. I got that from drawing my axis of symmetry. I see right there, it crosses there. But I got to find the y coordinate. So I plug negative 1 back in there. Y equals negative 1 squared plus 2 times negative 1 minus 3. See, this is 1, minus 2 is negative 1, minus 3 is a negative 4. So that should be where my vertex go to negative 1, negative 4. And that looks good, right? That fits our graph. We can put another point there. So our graph looks something like that. Okay, so we found the x-intercepts, the y-intercepts, the vertex. Now, if you want to use the formula just to find the vertex, that's fine. Sometimes it's easier to find the vertex right at the beginning. Let's do that on this next one. Let's find the vertex first. So I'm going to do that negative b over 2a. Find the vertex, right? A is 2, b is a negative 4. So b, if it's already a negative 4, do the opposite. So positive 4 over 2 times 2. So that's 1. Now I got to plug 1 back in to find out what I get. So y equals 2 times 1 squared minus 4 times 1. That would be what? 2 minus 4 is negative 2. So there's my vertex. So let's come over on our graph. We go to 1, negative 2. And there's our vertex right there. Let's find the y-intercept. So for the y-intercept, so this is the vertex. Let's make a note of that. To find the y-intercept, we plug 0 in for x. So we get y equals 2 times 0 squared minus 4 times 0. Well, that comes out to be 0. So the y-intercept's at 0, 0. So that is right there. So there is my y-intercepts at 0, 0. Let's find the x-intercept. Find the x-intercept, we plug 0 in for y. Now we got to solve that. This is a little bit tricky. When we go to factor this one, we haven't done this for a while, but when you go to factor, check for a common factor. You can take a 2x out of both of those. If I took a 2x out of 2x squared, I get x. Take a 2x out of 4x, I get 2. Now set them both equal to 0. So divide by 2. So x is equal to 0. So I plugged 0 in for y, I got 0 for x. There's one of my x-intercepts. If I add that 2 over, I get 2. Okay, those are my two x-intercepts. So 0, 0, and 2, 0. Okay, you can draw your axis of symmetry if you wanted. Okay, and we're good to go. That's what our graph looks like right there. We're going to skip past, this one's already factored. So when I go to find the x-intercepts, I just go x minus 2 equals 0, x plus 4 equals 0. Let's do this row. I was going to skip it, but let's do it. That means I get a positive 2 on this one. So that's one of my x-intercepts right there, my zeros. Minus the 4 over. So negative 4, 0. If you go halfway in between, I think that's 6 over. So if I go 3 either way, you can draw the axis of symmetry. What that means is that my vertex the x has to be at -1, but I don't know what the y is. So let's plug -1 in there. I get y equals -1 minus 2 times by -1 plus 4. So that would be -3 times +3. So that's a -9. So that's actually going to be a little bit off my graph. Let me slide this down a little bit. I think I go down to -8, so it's going to be down there. Okay, let's find the y-intercept. To find the y-intercept, I plug 0 in for x. So let's find the y-intercept. So if I put 0 in for x, I get y equals 0 minus 2 times 0 plus 4. That's -2 times +4, so that's a -8. So right here, a -8 is where it crosses. So you can put another point, right, because it's symmetric. Draw your graph. That's what it ends up looking like. I'm going to change this one just a little bit. I'm going to change this to a +5. So if you'll do that in your notes, get x squared plus 4x plus 5. Now let's find the vertex. So I'm going to do the -b over 2a using our formula to find the vertex. So that would be 4 is already positive, so make it a -4 over 2 times the a is a 1. Divide those. So now we can let's plug -2 back in and see what we get. Y equals -2 squared plus 4 times -2 plus 5. So y is equal to 4 plus -8 plus 5. Add all that up. I think I end up with 1. So if I go to -2, 1, that's where my vertex is. Hey, this graph is opening up. A is a +1. So just think for a second. If I draw that graph is never going to cross the x-axis. What that means is that there are no x-intercepts, there are no zeros, so there are none. So we don't have to find any. So one thing that can help is you can look for the vertex, see which direction it's opening, and sometimes it won't even cross the x-axis, and that can save you a lot of work. Now I still need to find the y-intercept, so let's plug 0 in for x. So I'd have 0 squared plus 4 times 0 plus 5. So that comes out to be 5. So my y-intercept, when I put 0 in, I get 5 back out, which is right there. And if you want to go on the other side, you know there's that axis of symmetry. There has to be a point on the other side. You can draw a pretty accurate graph there. So there won't always be x-intercepts, or there won't always be zeros, at least real zeros. There are other types of zeros we're not going to talk about right now, but they do exist. Okay, let's do this last problem here. So I'm going to find the vertex first. I'm going to do -b over 2a. B is already 8, so I'm going to get a -8 over 2 times 2. Divide those and get -2. Plug -2 back in. So I get y equals 2 times -2 squared plus 8 times -2 plus 6. We can plug that all in a calculator. Let's see. I think you end up with -2. So -2, -2, that's where my vertex is. That's where the axis of symmetry goes through. Let's find the y-intercept. So to find the y-intercept, I plug 0 in for x. So I'd get 2 times 0 squared plus 8 times 0 plus 6. Right, those are 0. They just go away. So it crosses at 6. Let's write our point up here. So 0, 6 is my coordinate. And I got my vertex down there. Okay, let's find the x-intercepts. I'm going to plug 0 in for y this time. Hey, one thing we can do here if you have a quadratic equation is if you have a common factor, you can divide by that common factor. So we could divide by 2 on both sides. I end up with 0 equals 2x squared divided by 2 is just x squared. 8 divided by 2 is 4. And 6 divided by 2 is 3. Okay, and then we can either solve it. Now, let's use the quadratic formula on this one, only because I want to show you that sometimes these don't come out evenly. This one does, but sometimes they won't. And so if they don't, you can always use the quadratic formula. Quadratic formula always works. So remember the quadratic formula is, put it up here. If you want to write this down if you don't remember, -b plus or minus b squared minus 4ac all over 2a. So that's your quadratic formula. So let's plug that in here. A is 1, B is 4, C is 3. So we get x equals -4 plus or minus square root of, that inside part we'll do in a second. 2 times A is 2. Let's plug in that B squared minus 4AC. I'm going to do it off the side. That would be 16 minus 4 times 1 times 3. So it ends up being 16 minus 12, which is 4. Square root of 4 is 2. So -4 plus 2 is a -2 divided by 2 is -1. -4 minus 2 is -6 divided by 2. Okay, those are my two x-intercepts. So it crosses at -1 and at -3, which fits our graph there. Okay, draw that. So sometimes, just to be aware in your assignment, there aren't a lot, but I think there's 1 or 2 problems where you may plug it into the quadratic formula and it may not come out evenly, and that's fine. Just use your calculator to figure out where those x-intercepts would be. Okay, so just remember, zeros are the same as x-intercepts. You plug 0 in for y, and you solve the quadratic equation. The y-intercept is you plug 0 in for x. It's pretty easy to find, and you find out where what crosses the y. To find the vertex, you can still use our formula, that -b over 2a, in order to find that. Okay, good luck. Let me know if you have questions.